Okay, I am going to read off a bit of this report from the UN under UNESCO. So there is a World Commission on the Ethics of Scientific Knowledge and Technology, and they did a report on the ethics of climate engineering. I'm reading this because there was this David Keith, a prof from Harvard, who's going around saying there is no harm in trying solar radiation management, which is basically going up and spraying some dust in the stratosphere to try to reduce incoming solar energy and slow down global warming. Volcanic emissions are used as an analogy for this experiment. Volcanoes tend to cool the climate, but volcanic eruptions also bring droughts and crop damages and all sorts of other issues. And David Keith runs a model and says the model shows that rainfall is actually going to increase. Well, models are not very reliable, plus I'm a bit worried that he couldn't even explain the model properly, because they had done this aerosol spraying experiment by tuning the solar constant and not actually putting aerosols in the model, because in the model aerosols have all sorts of feedbacks and so on. So without criticizing him too much, this is just a report which was done under COMEST, the Commission on Ethics of Scientific Knowledge and Technology, the process which was used to develop this report. So I'm going to just read a few sections of the long report. Relevant authoritative assessments and regulatory documents on climate engineering include, among several others, in the sense there are already many that have considered the ethics of climate engineering. So Royal Society 2009, Geoengineering the Climate Science, Governance and Uncertainty. There is a de facto moratorium on climate engineering by the United Nations Convention on Biological Diversity in 2010, prohibition of ocean iron fertilization by the London Convention and Protocol in 2013, United States National Academies of Sciences, Engineering and Medicine, Climate Intervention, CDR, sequestration and removal and sequestration, and so on and so forth. I won't read all of them, but basically people are worried about this, and there are many reasons why this is proposed. This is about reducing the risks of overshoot by Climate Overshoot Commission, in the sense that we will do it temporarily and just to avoid overshoot, in the sense crossing the 1.5 degree C threshold or the 2 degree C global warming threshold, and put us back on track to reach them by 2100 or stay under them by 2100. And then there are lots of scientific details about the climate shock. So if you are doing spraying of aerosols in the stratosphere and you stop it, what happens to the system? How does it recover? And so on and so forth. So keeping all that in mind, I'll just read about intergenerational ethicists here. So intergenerational ethicists work to understand and define issues impacting on intergenerational justice by analyzing and reflecting on the extent and nature of relations among different generations. Two of the core questions they consider are: do we have a moral obligation to future generations at all? If so, what do we owe them? How do we know what values to be bequeathed to the future generations? Driving intergenerational justice should be, given the power asymmetry between the current and future generations, and the fact that there is no direct reciprocity between the contemporary and future generations. Well, these are kind of normative questions, but we have already colonized the future with our climate change activities, greenhouse gas emissions, which are going to affect them and their future. So adaptation and mitigation are kind of trying to change this, which again affects their future. So the technical, ethical and risk dimensions considered for the ethics of climate engineering is through solar radiation management and carbon dioxide removal. Though solar radiation management and CDR, carbon dioxide removal, both may have the potential to halt and reverse global warming, there are major differences in their intended modes of action and their ethical implications, which will be discussed later in the report. These major differences include the time scales over which they might work, the possibility of reversal, the degree of sensitivity to which they might be tuned, the spatial regimes of their potential effects, locally limited or global, their possible effects on natural processes, possibly unknown consequences. So I mentioned volcanic eruptions and droughts and so on. The spraying dust would immediately block sunlight and have some effects on energy balance, and then we have to see how it percolates into the system in terms of redistribution of rainfall and so on. But carbon dioxide removal is a slower time scale and considered much more benign in the way, since CO2 is well mixed, long-lasting gas that we are emitting. So I will just jump to recommendations. Whereas the most important, urgent and indispensable climate action are mitigation and adaptation, which we accept as necessary and important and manageable, COMEST encourages member states and all relevant stakeholders to adopt the ethical principles outlined in this report when making decisions on climate actions, including climate engineering, and recommends the following, not listed in order of importance. So it's just a summary of the issues of governance. Decision makers should pursue comprehensive, open and responsible collaboration and constant monitoring of all climate actions, including climate engineering technologies. This is necessary due to the intrinsic nature of decisions on climate action, which might not be fully ethically defensible in all cases. Decisions on climate action, including climate engineering, should be taken according to an ecosystem flourishing approach and intergenerational and distributive justice considerations. Decisions on climate engineering techniques should be made considering the scientific knowledge on which they are based, the specificity of technology under consideration, the degree of uncertainty in the likely outcome of the implementation, the likelihood or otherwise of reversing a proposed deployment, and of course the cultural assumptions and implications with the distribution of risks. If the global south ends up paying a high price again, like we did with the unintended experiment of putting greenhouse gases into the atmosphere, into the system, then we're just creating another big problem. Member states have an obligation to prevent harm to their citizens, and this includes protecting them from the harmful effects of climate change. So if the research on geoengineering, climate engineering, solar radiation management, various alkalinity enhancement, cloud brightening and so on and so forth, if they actually encourage people, firms or governments to try those approaches, technologies, geoengineering, then we have to worry about all these, about preventing harm and making sure the distributional impacts are actually somehow tracked, and there are methodologies to deal with them in terms of compensating or mitigating the impacts and so on. So therefore it's necessary for member states to introduce legislation that in accordance with international standards, mainly those by the United Nations, regulates climate action, including climate engineering. Member states should consider the transboundary impact of their decisions on all human beings and ecosystems as a global responsibility. You do something in your country, US cannot go and do solar radiation management on its land and think that's only affecting them, but you will have unintended consequences everywhere. Transboundary impacts are guaranteed, right? So as such, they are encouraged to provide and facilitate access to information and initiate both international and cross-cultural dialogue on these impacts. There may be religious implications. If some religion believes we are not allowed to do such things according to their religion, then how do you justify it to them? Is it our job to do these godlike acts and engineer the climate in the name of good intentions? Regionally based agreements among countries belonging to a geographic area that share environmental resources or problems should be encouraged in order to avoid risks of unequal spatial distribution of effects. Any proposal to deploy climate engineering technology should be combined with practical methods of mitigation, especially of unintended consequences and reversibility ideas. Any use of climate engineering techniques as a weaponization of geoengineering should be universally banned. In fact, if you go back and look at what thoughts were coming along when the initial big computer, mainframe computer, was invented, the EC1030, I think, there were ideas that weather could be modified for fighting wars. Okay, so always there are some crazy ideas. Participation and inclusiveness are very important, so I won't read the details, but member states must ensure that vulnerable, neglected and marginalized individuals and groups, women, youth and indigenous people, are included as key stakeholders in the development and implementation of policies, decisions and activities in all matters of climate action governance, and their interests are properly taken into account. Role of scientific knowledge and research, we should read this. Scientific research on climate action, including climate engineering, should be free from unjustified interference by political or economic interests and have the aim to better identify and reduce the scientific and societal uncertainties over the efficacy, benefits and risks of the different technologies. You know, the standard ethics of scientific knowledge and technology. Scientific research on climate change, including climate engineering techniques should be encouraged when it consists of indoor research investigations involving theoretical analysis, social science research, computer simulations and modeling, and laboratory experiments contained, reversible. In the case of small-scale outdoor SRM experiments, solar radiation management experiments, and potential large-scale SRM deployments, in addition to following the ethical standards of research, attention must be paid to potential conflicts of interest, transparency and accountability, cultural implications, different disciplinary perspectives, and public engagement. Finally, any decision on climate action, including climate engineering, should be based on scientific evidence and data and adopting effective interdisciplinary approaches. Sharing of scientific knowledge and research data is a global responsibility for anyone involved in climate research, including climate engineering, in order to ensure informed policymaking and public debate on climate change. The impact of climate action, including climate engineering technologies, in case of deployment, should be regularly monitored to inform decision makers at all levels. Even a village administration should know about what is being done that could potentially affect them, right? So it's not trivial, doable, and must be done because it seems fairly obvious that some climate engineering is going to be attempted either by governments or by individuals with a lot of money, or individual scientists supported by people with money like Bill Gates, let's say. So we have to be very careful and have these things codified and agreed upon. Okay, so I just wanted to include that here. See you in the next topic.